Hello everybody. So in this our second tutorial we will learn to simulate a distillation column, and it is quite difficult comparative to other distillation column, other unit operations in any simulation software. So we will go to this hardest one so that the rest could be far easy for us. So here I started new case, then I add the number of components of my system. I add water, okay, and 2 propanol here, this one. So this is my system components. Now I add the fluid package to them. As I said before that we have to do literature survey to find out which property package is most suitable to the components which we are using in our system. It is not always that he can tell you which property package you have to use, and if you do not use correct property package, thermodynamic fluid package, your all simulation is meaningless. For example, sometimes hysys also tell you this is not correct fluid package or something like that. For example, if I choose equation of state being Robinson, we will say no, this is not recommended for 2 propanol. So he give me the option delete component or keep components. I simply cancel this action and I know which property package is better for this system, that is NRTL. You also do have to do your literature survey. Okay, NRTL is okay. I close down this. Now the number of components are 2 and property package is NRTL ideal. So these are the second step you have to finish. Then the third step is enter simulation environment. Here I just simply put a distillation column, and for your reboiler duty and condenser duty, that is the second stage of this simulation. So CQ is my condenser stream. I just name it and it will create it there, and RQ is my reboiler stream, energy stream. I am using full reflux, means there would be no liquid product. Here it's a liquid, this is vapor. The full reflux means my all liquid goes into the column reflux and I take only vapor as a product. Actually my product is not comes out from the top, it comes out from the bottom, and it is pure IPA, 99%. So you see, once I created all the streams attached to this distillation column, minimum required stream that need to be attached, this next button enabled. Now condenser pressure, you have to decide on which pressure you have to operate your distillation column. I operate it slightly above atmosphere, so there is positive pressure, positive flow, okay, and the pressure drop is around 1.5 0.7 atmosphere. I made it. So here next, this is 1.7. By mistake I click on this outside area and it takes 1.7 kilopascal, so there is a negative, the pressure reversal. Your condenser is at high pressure and your reboiler is the low pressure, so that is the warning came. Anyway, don't worry about that, I corrected it. Now condenser pressure, reboiler pressure, around 50 kPa pressure drop across my column, that is normal or more for this 10 tray column. Now next, I do not put any optional conditions because exactly I don't know. I do not give any vapor rate flux ratio although I can give the paper rate, but I will use different page for giving them. That would be easy. Here you remember that you only made the connection to distillation column and you give only condenser and reboiler pressure, that's all. Now this column, okay, column property view opened. Before that I have to complete my feed specification, that because that we have to give them. Temperature say 20 degrees centigrade, pressure I will say 1.3 atmosphere, slightly at above atmosphere. Molar flow is 100 kg mole, just to keep it simple, and water is 0.05 mole fraction. By default it is a mole fraction. You can choose any radio button, no need to go to the calculator and convert the things. You can convert it right now here, clicking this one. Okay, so my this feed stream is fully defined, and now I go to this page. Double click onto this distillation page and click on the monitor. Here are the specification: reflux ratio, overhead vapor rate, flux rate, bottom production rate, degrees of freedom are 0, these are too active. Basically there are a number of equations for solving the distillation column and the variables, so you have to give this constraint so that the degree of freedom is 0, means you will get the unique solution. So I remove this flux ratio constraint. I would like to give this product specification. My product, that is column component fraction, should be come out from the reboiler. Mole fraction of this liquid should be 0.99. I mean I need 99% pure 2-propanol from reboiler, right? My feed is around 95% and my product should be 99%. So I make this component fraction and active, and then second bottoms rate. Okay, now bottom rate. Now here you have to give the rough good estimate. I mean I am putting 95 kg mole of IPA, so, and I want 99% in the bottom, so it means I cannot get more than 95, but that is 100% recovery, and usually you get only around 90 to 92% recovery in actual, so in hysys also. So I should put around 90 here. Let's see, I can get this much of recovery. No, cannot get. The simulation is still running, and for such a small system it won't take this much time. So I stop this and I put this 88 kg mole. See, no, still I cannot get that one, so I will put it 87, 86. Now run. Yes, I can get this much. Let's increase this 87 and see. No, I cannot even get 86. Sorry. Yes, I can get 86. So my distillation column is converged and I am getting 86 kg mole per hour, and composition is 98 point, approximate 99% 2-propanol. That's all for now. Now you today we learned this distillation column simulation. Here for one feed and 2 outlets we have 2 degree of freedom, means you have to give 2 constraints here. Yeah, specific you can also add here, and monitor you can see the specification you added here, and you can remove even these unnecessary, or you can just estimate them to see update inactive like this. So that's all for now. Thank you.